let's now talk about arcs and chords of circles. So we're going to be talking about how to find those measurements and lengths. So it says a central angle is an angle whose vertex is the center of the angle. So for example, if I was going to draw a circle right over here, and I was going to create an angle coming out from the center. So here's my center, here is an angle. The central angle would be this one right over here, okay? That's called the central angle. An arc is an unbroken part of a circle consisting of 2 points called the endpoints and all the points on the circle between them. So I'm going to use that same example that I just drew. An arc would be this right over here. That right there is an arc, or I can go the other way and say that right there is the arc, okay? So today we're going to be talking about how do you find the measure of that arc. Now, arcs are also measured in degrees just like angles are. And you can have two types of arcs. You can have a minor arc or you can have a major arc. So a minor arc is an arc whose points are on or in the interior of the central angle. So this is my central angle, right? Minor arc is on the interior. So minor arc is that part right there. So when I look at the diagram that I'm given, it says the measure of a minor arc is equal to the measure of the central angle. So measure of arc AC is equal to the measure of angle ABC, which is equal to X. So if I have my angle right over here, if I have my central angle, then this minor arc that's created is equivalent to this measure right over here. So this is also X degrees, okay? Now that angle has to be the central angle. The major arc, like I said, is on the other side, is the other type of arc that's created. So same thing, if I'm going back to my original drawing, this one right here is the major arc. So the major arc is an arc whose points are on the exterior of that central angle. And the measure of the major arc is 360 minus the measure of its central angle. So this right here is my major arc, and it is going to be 360 minus X degrees, okay? And that makes sense, right? We know that in a circle there are 360 degrees, so if part of that is taken up by X, then what's left over is 360 minus X. And finally, if the endpoints lie on the diameter, the arc is a semicircle. So notice that I have a diameter right over here, EG, intersects that center. So EFG, arc EFG is a semicircle, and since it's a semicircle, it is 180 degrees. Okay, because we know that lines are 180 degrees. Now let's quickly talk about how you name them. Minor arcs may be named by 2 points, but major arcs and semicircles must be named by 3 points. So if you look on our diagrams, notice that this major arc, they added another point onto that circle, so that way you would have a third point to be able to name it properly. If you only use 2, if you say AC, it's understood to be that right there. But if you say ADC, that makes it more specific. And you're like, oh, okay, I have to intersect through that D. If you didn't require that third point to be a major, how would you know which one to use, right? Same thing for the semicircle, I have to say EFG. All right, so now let's go ahead and do an example of how you find different measurements. So again, remember, anytime we're given 2 points, it's going to be a minor arc. If we're given 3 points, it's going to be a major arc. So it's saying using the arc addition postulate, find the measure of arc AE. So if it says arc AE, that's going to be a minor arc, and I'm going to go from A to E. Remember, the measure of any arc, any minor arc, is equivalent to the measure of its central angle, which is this angle right over here, because angle AFE creates minor arc AE. So I can say 97.4 degrees. Measure of arc AED. So I start at A, I travel through E, and I stop at D, which means the angle that's created is that right there, okay? So AED is going to be that angle measure right there, which is together 97.4 plus 52 degrees. And I'm going to write that down so whenever we go back and look at our notes, we know where this comes from. 97.4 plus 52, which is going to be 149.4 degrees. Find the measure of arc DC. Uh-oh, I don't really have any information there, okay? However, I see that this right here is a line that goes through the center. And any line through that center that goes from one point of the circle to the other part is called our diameter. And we know that any arc created by the diameter is a semicircle, which has 180 degrees. So we know that this arc is 180, which means this right here is going to be 180 minus 97.4 minus 52, okay? Which ends up leaving us with 30.6 degrees. What I want you to do now is pause the video and see if you can do numbers 4, 5, and 6. All right, next one says find the measure of arc BC. That's going to be this arc right over here. Okay, and again, if you're struggling, notice that this is a diameter, okay? Any chord that goes from one part of the circle to the other through the center is the diameter, which creates semicircles. And these semicircles are really going to help us find our measures. So if this right here is a line, which creates this semicircle right over here, that helps us because we can use this measure and subtract it from 180 to find that measure right over there. So we know that that right there is going to be 180 minus 52 minus 30.6. And that, of course, is 97.4. Now, you might be thinking, I already knew that. These are vertical angles. You might be thinking that. That's good. You should be thinking of these things, okay? I just wanted to show you another reason, another way, another method for you to find that same answer. And of course, that confirms to us that that in fact is the correct answer. All right. Since that central angle is 97.4, that of course means that my arc is also 97.4 degrees. Next one says find the measure of arc EAC. Notice that they're using 3 points, which means this is a major arc. So I'm going to go from E to A all the way around to C, okay? EAC. So I can do it several ways, right? I can add up all of these different angle measures, or I can use that definition that was on the top of our paper that says a major arc is 360 minus the central angle of the minor arc. So I can do 360 minus this measurement right over here. (360) minus 52 minus 30.6, which is 277.4 degrees. And so that's the measure of that angle and also the measure of that major arc. The next one says find the measure of arc EAD. So I'm going to go one step further and I'm going to go all the way around to D. Same thing, I'm just going to do 360 minus 52 this time. Okay, not 52 and 360, which leaves me with 308 degrees. So again, the measure of the central angle is equivalent to the measure of the minor arc that's created. All right, now let's do a little bit more. The next set of theorems talks about different parts of different things that are created because of these central angles. So it says in a circle or congruent circles, congruent central angles have congruent chords. So notice in my diagram that this central angle and this central angle are congruent, and I can see that because the markings are the same. If those central angles are congruent, then this chord that's created and this chord that's created are also congruent. That's what that theorem tells us. The next one says congruent chords have congruent arcs. Well, if this chord is congruent to this chord, then this arc is also congruent to this arc. Okay? And then finally it says congruent arcs have congruent central angles. So if this arc is congruent to this arc, then this central angle is congruent to this central angle. So they all kind of play hand in hand with one another. So in this example, it says segment TV is congruent to segment WS. And that's already marked for us if you notice. It says find the measure of arc WS. So our job is to find this arc right over here, question mark. Now, what we just learned is since this chord is congruent to this chord, we know that this arc is congruent to this arc, which is great because we know I know an expression that represents each of those arcs. So if I want to solve for the value, I just need to know the value of the variable, which I can easily find by just setting those equal to each other. So I can say 9n minus 11 equals 7n plus 11. And I just have to go solve. I'm going to start by adding 11 to both sides and subtracting 7n from both sides. Now, if you are not comfortable doing all of that at once, then don't do it all at once. So, do it in two different steps. Negative 11 plus 11 is 0, and 7n minus 7n is 0, which leaves me with 2n on the left and 22 on the right. Divide by 2, which means n is equal to 11. Okay? Now that we have n is equal to 11, all I have to do to find the measure of that arc is substitute it back in. So I can say measure of arc WS is equal to 7n plus 11, and we're just going to go substitute. Lots of 11s in this one. 77 plus 11 is, of course, 88. So I can say measure of arc WS is 88 degrees. Now on the back, we're going to talk about some perpendicularity theorems. So the perpendicular chord bisector theorem says if a diameter of a circle is perpendicular to a chord, so let's look at our diagram before we go on. So I have my diameter, and here is my chord, and here they are perpendicular, okay? Then the diameter bisects the chord and its arc. So remember the word bisect means intersects into, and it intersects and creates two congruent parts. So that tells me that segment FH and segment HD are congruent to one another. okay? It also says it bisects the chord and the arc. So here's the chord that's been bisected, and here are the arcs that have been bisected. Now the cool thing is, it's bisected on the other side as well. So these arcs are also bisected, okay? So now let's take a look at the perpendicular chord converse. The converse said if one chord of a circle is perpendicular, if one chord of a circle is a perpendicular bisector of another chord, then the first chord is a diameter. So if this ends up being a perpendicular bisector, then this segment right here has to be the diameter, which means it intersects at the circle. All right, so it says find NP. So our job is to find this whole length right over here. And I see this perpendicularity right here. And you might be thinking, oh, but it only matters if it's the diameter. Remember, the radius is just half the diameter. Even though they didn't draw this part right over here, doesn't mean the same rules don't apply. So now that we know that those have been, that is its perpendicular bisector, I can say that is congruent to that. And since I'm looking for NP, let me call each of these segments X, and now I can say, all right, let me go and solve. Now here's the really cool thing. Remember, a radius goes from the center to any point on the circle, right? Okay, that's really cool. So what that tells me is, hey, I know the length of the radius. 8 and 9 together make my radius, which means my radius is equal to 17 units, whatever those units are. And guess what? Because this is a 90-degree angle, that means this is also a 90-degree angle. And I can really easily solve for X because I can create a right triangle right over here. Okay? Now you might be thinking, yeah, but I only know the 8. I'm missing 2 pieces. You're not missing 2 pieces. You know why? Because from R to N is also a radius. Isn't that cool? So I know that I'm looking for X right over here. And I know that I'm given my radius, which is 17 that we talked about earlier. And now I just have a right triangle, and I know how to solve that. I can use Pythagorean theorem. I can say 8 squared plus x squared equals 17 squared. And now I can go solve. 64 plus x squared equals 289. And then I have to subtract 64 from both sides. So x squared is equal to 225, which means x is equal to 15. That's great. I'm not done because that wasn't my final answer. That's not my job. My job isn't to solve for x. My job is to find NP. And NP, of course, is 2x, which means 2 times 15. So NP is equal to 30. Okay, anybody who says that math doesn't use creativity, look at how the creative type of thinking that you need in order to be able to solve that problem, okay? You have to make sure that you're utilizing all of the things that you know. All right, let's go do one last example. An archaeologist finds a part of a circular plate. What was the diameter of this plate to the nearest thousandths? Okay. Well, clearly I only have part of this plate. So even if I can't find the diameter, if I could just find the radius, I could just double it and I would get the diameter of my plate, right? So I see that this segment is bisected by a perpendicular section right over here. Our perpendicular chord converse says if one chord of a circle is a perpendicular bisector of another chord, so look, this right here is the perpendicular bisector of this chord right over here, then the first chord is the diameter. So that tells me this right here is my diameter, however far out it goes, okay? So that tells me that this section right over here is the radius, right? And I can draw that radius wherever I want. I can draw that radius wherever I want. I'm going to draw it right over here because that's going to allow me to use this 90-degree angle right over there. Now notice they tell me that this chord right over here is 7 inches. If the whole thing is 7 inches, then of course this little piece right here is 3.5 inches. Okay, and then I can just call this X. I've got 6 inch right here. This distance right over here is 6 inches. And I can again use Pythagorean theorem. I can say 3.5 squared plus 6 squared equals X squared. Now, if you want to call X R, so you remember that it's the radius, then by all means go do that. And I can just type that into my calculator because it's involving decimals and all that good stuff. It is a real world problem, so you are allowed to round. And in fact, it does say to the nearest thousand. So make sure you do that correctly. So what ends up happening is you end up with 48.25 equals X squared. And we take the square root of both sides. And I'm going to leave it like that for now because what I'm going to have to do is double it, right? So remember, we're going to leave it until our final answer. I don't want to round until my final answer. And I know that my diameter is 2 times the radius, which means 2 times the square root of 48.25. So the diameter is approximately 13.892 inches. And that's it. It involves a little bit of creativity on your part, but that's what makes it so cool and fun.